Okay, so continuing our studies on matrices, let's explore the associative property for matrix multiplication. And to do that, we'll continue using our fruit stall example from our previous video. So I have now a table of the wholesale price for each piece of fruit that we are selling in our fruit packages. So the store is buying apples at 15 cents each, oranges for 15 cents each, bananas for 20 cents each, peaches for 30 cents each, mangoes for 40 cents each, and pineapples for 50 cents each. So let's write this table as a column matrix. So I shall call the matrix W for wholesale, and we'll list all the data in a column. And from our previous example, we have the M matrix, which represents how many of each package we sold in the months of July, August, and September. And we also have the P matrix, which details how many of each fruit are in the 4 different packages that we're selling. Alright, so in the last example we also found the product of the matrices M and P, which we called matrix Q for quantity, which describes the quantity of each item of fruit that we sold in the months of July, August, and September. Okay, so just to recap, in the Q matrix, the columns represent the items of fruit. So we have apples, oranges, bananas, peaches, mangoes, and pineapples. And the rows are the months, so we have July, August, and September. Okay, well, since we have the quantities of each fruit for the months of July, August, and September, it follows then that we can work out the wholesale cost for all of the fruits in these months by multiplying the matrices Q and W. So the quantities of each fruit by the wholesale cost of each fruit. And let's call this new matrix matrix C for cost. Alright, so let's make a copy of the Q matrix and we'll multiply it by the W matrix. And carrying out the operation, if we take the dot product of each row with the column, okay, and all these numbers add up to 171.1, 177.95, and 130.15. Okay, so what this means is that we had to spend $171.10 in July for all the fruit that we sold. We had to spend $177.95 to buy all the fruit that we sold in August, and $130.15 to buy all the fruit that we sold in September.
Now let's find another matrix product. Let's find the product between the matrix P and the matrix W. So the matrix P represents the quantities of each fruit in each of the packs that we're selling. And of course, again, W is the wholesale price of each fruit item. So what we're doing here is we're finding the pack price, so the cost, the wholesale cost of each pack. So remember, we're selling 4 packages of fruit, and we'll find the cost of each package with this product. So let's call this product the U matrix for the unit cost of each pack. Okay, so to recap again, the columns denote the quantities of fruit. So we have apples, oranges, bananas, peaches, mangoes, and pines. The row represents the packs, so we've got a basic pack, a variety pack, a deluxe pack, and a super pack. So carrying out this product, so again, adding up these numbers, the price for the basic pack is $4.60. The price for the variety pack is $4.85. The cost of the deluxe pack is $6.90. And the cost of the super pack is $9.90. So each package of fruit costs the store these prices.
Alright, let's do one more matrix product. Let's find the multiplication of the M matrix by the U matrix. And just to recap, the M matrix represents the numbers of each package we sold in the months of July, August, and September. So the columns denote the packages, so we've got a basic pack, a variety pack, a deluxe pack, and a supreme pack. And of course the rows denote the months, so we've got July, August, and September. So the product of this multiplication is and adding up the numbers we get 171.1, 177.95, and 130.15. And these numbers look very familiar because these are the exact same numbers as the matrix C. And this was the whole point of this video, because we've found two ways of finding the matrix C. Initially, we found C was equal to the product of the Q matrix times the W matrix. And in the second instance, we found that the C matrix was equal to the product of the M matrix by the U matrix. Now, Q was the product of matrix M and matrix P. And U was the product of matrix P by matrix W. So what we have shown here is, as long as we maintain the order of the matrices that we're multiplying, then matrix multiplication is associative. So it doesn't matter how we group the multiplication, whether we do the product of M and P first, or the product of P times W, as long as we maintain the order of the matrices in this equation, we will get the same result. So thus we say that matrix multiplication is associative. Even though we've shown this as a fact, a general proof for the associativity of matrix multiplication is actually quite difficult, and we can really only efficiently show it on smaller examples like these. Okay, so the take-home message of this video is that the multiplication of matrices is associative. So that'll do it for this video. If you have found it to be helpful, please give me a like and share this video and subscribe to my channel. And these videos do take me a lot of effort to produce, so I would really appreciate any small donation that you can make, as this will allow me to create more videos and help more math students of the world. Thanks very much for watching, and I'll see you on the next video.